Good morning, sir.
Sir, good morning.
Shall we start, sir?
Yeah, we can start. Am I audible?
Yes, you are perfectly audible, sir. Participant, are you able to hear this, sir?
Yeah, audible.
Yes, sir.
Thank you. Welcome all the participant and the resource person to this 5 days online FDP on smart manufacturing challenges and research. And today with us, our first speaker of this FDP, Professor R. Thirumalai, sir, he's associated with the Department of Mechanical Engineering, DN, DNGITI, Coimbatore, Tamil Nadu. Sir has Sir has completed his PhD from Anna University, Chennai. Before that, Sir did sorry, sir. Sir did MTech from NIT Trichy. Sir has many research paper in his credit, number of journals, 12 journals. Sir is also currently guiding 6 PhD scholars and awarded 3 PhD project. Sir is academically uh, active in guiding PG, UG and the PG students also. Sir is till date, Sir has guided 32 PG project. Sir, Sir is also associated with the journal editorial board, like managing guest editor of Elsevier's Metals Today Proceeding, managing guest editor of IOP Journal of Physics, Chiang Mai Journal of Science, and Sir is also international exposure. Sir is also given the invited keynote speaker in the conference GSMI 2017 at Prince Songla University, Hatia, Thailand. With this brief introduction, I would like to request Sir to kindly take over the session. Over to you, sir.
Thank you, Dr. Tamang, for your nice introduction. So myself, Dr. Thirumalai, I would like to thank the organizers of Northeast Regional Institute of Science and Technology for giving me an opportunity to share my knowledge on smart manufacturing for the AICTE Atal sponsored faculty development program on smart manufacturing. So my sincere thanks goes to the head of the department, Professor Mato sir, and the Professor Dr. Chandrasekharan, those who are my close friends for the past several years, and they are also in my research career in several avenues also. And I would like to also thank Dr. Santosh Tamang for giving me an opportunity to deliver my speech on smart manufacturing. So today, the first session of this faculty development program. So it is the session is on sustainability and research perspectives of smart manufacturing. So nowadays we are focusing only on e-learning. We can able to find the e-learning is bringing a dramatic changes in the educational landscape, and it provides depth and quality of learning in most of the several institutions. We can able to find when we are in pandemic for the past 2 years, almost all education institutions we are going with e-learning. And what is the benefits of this e-learning? It increases the educational opportunities of the students worldwide, because we can able to hear a lecture from many experts worldwide throughout the globe. If I want to deliver a lecture to a student of an university at London or at America, I can do it very easily. So these are the specific benefits of e-learning, and it saves times, it saves money, and with this online e-learning, the learners can access the contents anywhere and anytime, and it improves the performance and productivity. It improves the performance and so here we can able to find out we are speaking about the automation process. The automation. Aman?
Yes, sir.
Okay. Some disturbance is there.
Okay, sir. You may continue, please, sir.
Yeah. Okay. So we can able to find out the automation has been in existence from the Stone Age, and we can able to find it out in Bronze Age where the tools were being developed, and then from the Iron Age, and then the Dark Age, Modern Age, and now we are sitting in front of computers, and it is in the age of computer age. We are speaking about complete manufacturing, which is going to be take place only with the aid of a computer. So the bank theory doesn't exist. So it doesn't stops even when we are in the computer age. It starts from Stone Age, and until computer age, it is the same phenomenon we can able to find out. And we are going to see about what is meant by sustainable manufacturing, and it is also called by the name called as green manufacturing. So when we speak about the green manufacturing, so the combination of the green machines, green manufacturing process, green products, and the clean power, we can able to say the combination of all these things will come under a single term, which is called as green manufacturing. So this green manufacturing is also given by the several other terms, which is called as eco-facturing or eco-manufacturing. So here the sustainable manufacturing will come into existence of picture, which stands on the three different pillars. The first pillar is the social pillar, and second one is the environmental pillar, and third one is the economic pillar. So when we speak about the environmental pillar, we should see about how far the waste management is being taken care by in manufacturing industry, how the energy consumption is being done, and in what way we can able to find the manufacturing cost is being reduced so that I can able to improve the manufacturing process. When we see about the social factors of sustainable manufacturing, so it speaks about the operational safety of an employee who is working under the industry. And we should speak about the personal health, how far the personal health is being improved or it is being taken care by the industry for the employee. And then finally, when I speak about the environmental impact, so it will also have a higher impact, higher influence on the sustainable manufacturing process. Then we will find out what is the concept of sustainability and sustainable manufacturing. So the sustainability will stand on three different pillars. One is the social pillar, second one is the environmental pillar, and third one is the economic pillar. So the sustainability process will provide less damage to the environment. It will pay more attention to this society, and it provides the economic benefits also. So everything we are taking it from the earth and we are going to leave it to the earth also. So we should be concentrating on three different factors to achieve a sustainable manufacturing. The first one is social manufacturing, and the second one is we can able to find the environmental factors, and third one is the economic factors we are going to concentrate. And this is the evolution of sustainable manufacturing. So we can able to find the how far the sustainable manufacturing is being evolved from the existence. Traditional manufacturing started in the year of 1980. Traditional manufacturing started in the year of 1980. So automatically what happened? So the process of manufacturing is started. The process of manufacturing started, and then it started from 1980. Okay. So it started in the year of 1980, and then it is only in its process, but we can able to find only a gradual growth. We can able to find only a gradual growth, and in all these things, we can able to find the manufacturing phenomena in several aspects are taking place. It started from turning, machining, milling, until the concept of smart manufacturing, CNCs, automations. Everything is been taken into considerations. So here we can able to find the after the traditional manufacturing is being taken into consideration, there comes the concept of lean manufacturing. So when I speak about lean manufacturing, we always concentrate only on waste reduction techniques. So we will be seeing how far we can able to reduce the waste so that we can able to improve the environment. We can able to improve the environment. So then the lean manufacturing came into existence immediately after traditional manufacturing, and it lasted gradual increment. We can able to find out lean manufacturing came into existence. Several industries adopted this lean manufacturing techniques also. After this lean manufacturing, then we concentrated towards the environmental winning manufacturing, that is called green manufacturing, where these three are based manufacturing philosophy, where the three are, it speaks on how we can able to reduce the waste, how we can able to reuse the products, and in what way we can able to recycle the uh, the materials and the other properties which are available in industries, we can able to do it. So here, this green manufacturing is also superseded by the sustainable manufacturing, which is an innovative manufacturing and which speaks on 6R based technique, which speaks on 6R based technique here. So here, the 6R, they are speaking on how we can able to reduce, how we can able to reuse, recycle, recover, redesign, and remanufacture. So in all these cases, we can able to find the sustainable manufacturing is coming into existence into picture. Then comes the pillars of sustainability. So where we have the environmental, where we will cover the planet, and then the economic, where the profit, the minimization of the cost which is involved in the production process will be reduced, and societal benefits, how we can able to improve the employees' health, how far we can able to improve the morality of the employees. All these things will come into picture of sustainable manufacturing. Then comes, what is the difference between sustainable manufacturing and the generalized manufacturing, what we are seeing. So when we speak about manufacturing, so we have mechanical and physical and chemical process to modify the geometry, properties, and appearance of a given starting material in making this to a new finished product or a part. So manufacturing, we have several process we have. So when we take about a turning process, initially we will have the raw material. The raw material will be entering into the industry, and the geometry of the raw materials will be totally will be modified, and the properties will be totally modified, and the final shape of a particular product will be given to the raw material. Thereby, I can say that a manufacturing has been done so that we can able to obtain a new finished product. Whereas sustainable manufacturing, it speaks on the basis of manufacturing. Along with the basis of manufacturing, it also speaks on several aspects, which states it should be a non-polluting, it should conserve energy and natural resources, and it should be economically sound and safe for the employees, communities, and consumers. So the sustainable manufacturing, so it speaks on the basis of manufacturing. Along with that, it speaks on environment, how far we can able to improve the environment, how far we can able to improve the social aspects, the people those who are working in the industry, and along with that, it also speaks on the economic parts, how you can able to maximize the profit for an industry. So the sustainable manufacturing process, so it generates minimum quantity of waste. So this is what we are speaking in lean manufacturing. So in case of lean manufacturing, the waste reduction is the general philosophy of lean manufacturing. Similarly, the minimum quantity of waste is to be decreased. So in the case of sustainable manufacturing, and then we will demonstrate how far we can able to improve the environmental performance and energy efficiency. So thereby, I'm improving the societal impact, that is safety and personal health of the employees also. So sustainable manufacturing is a branch of sustainability that deals with economic, environmental, and social objectives of manufacturing activities. So there are some other words are also defined here when we speak about sustainable manufacturing. All these words are very similar to sustainable manufacturing, and we can say we have green manufacturing, a clean manufacturing, environmentally conscious manufacturing, environmentally winning manufacturing, environmentally responsible manufacturing, eco-friendly manufacturing, and sustainable manufacturing. All these words are very similar. So in most of the cases, so these words are, it is being used for sustainable manufacturing, where it speaks on the three factors which we are going to control for the betterment of the industrial society. And the objectives of sustainability in manufacturing, it speaks on how far we can able to minimize the manufacturing cost, how the energy consumption can be minimized, how we can able to reduce the environmental impact, and how we can able to improve the personal health, how operational safety can be improved, and how the waste management practices can be improved. So there are certain indicators for sustainable manufacturing. As said earlier, we have only three pillars. One is economic, other one is environmental, other one is social. And there are some indicators for this sustainable manufacturing are also available. So when we speak about the economic performance, the several indicators are manufacturing cost, energy cost, quality of products, production efficiency, productivity, technology, and supply chain network. So here, how all these economic performances they become an indicators. We will just see take one or two examples over here. So when we go for a manufacturing cost, so here definitely the cost of manufacturing should be very lesser. So I cannot say I have achieved sustainable manufacturing by improving the investment for the manufacturing, by improving the cost for manufacturing. When the cost of the manufacturing is highly increased, there is no point of saying that sustainable manufacturing has been increased. So I should say that the manufacturing cost should be reduced. I should say that the amount of energy conserved for doing a product should be also reduced. I cannot say when I use more higher amount of energy, I can able to achieve sustainable manufacturing. There should be no compromise in quality of products. For when we are doing a product with lesser amount of by having high compromise on the quality, automatically the products will not work properly, and ultimately the manufacturing sustainable manufacturing will become a failure. So in this case, when I want to say that if I want to have a sustainable manufacturing, I should also provide a high quality of products which should have a lesser amount of manufacturing cost, and it should also conserve lower amount of energy. Similarly, I should also go for with usage of highest amount of technologies. I should have a high amount of production efficiency, and I should have in the supply chain network should be also facilitated. So here, the next impact is the environmental performance. How far we can able to improve the environment of a sustainable manufacturing. So in this case, we can able to find there are several indicators are here for sustainable manufacturing. They are material and water usage. It is energy consumption, water, land, and air pollution, restricted waste generated, emission release. So in what ways all these indicators will help in sustainable manufacturing? So here the amount of wastage should be lesser. So I should always see that I will be improving the environmental performance only when the amount of the usage of water and materials are very lesser. So when I say the amount of the material used is very higher, then I obtain and sustain in manufacturing, then it is a failure. So the amount of the usage of the raw materials and the resources are to be minimized. I should go for lesser amount of energy consumption. So during my process of manufacturing, I should reduce the water pollution. I should reduce the land and air pollution also. Air pollution is becoming a very big threat in the past days, but nowadays when we are moving into sustainable smart manufacturing industry 4.4, this air pollution is being under control. We can able to find that the air pollution is being under control. I should restrict the waste generated. So from the industry, there are so many amount of waste will be coming out. So the scrap materials and then the hazardous waste, the coolant, lubricant waste, all these things will come out. So all these waste are to be restricted to minimize the amount of waste which is being coming out from the industry. So automatically when I minimize the amount of waste which is coming out of the industry, I can say the emission is being released is in normal parameters, so that the amount of emission of the waste products is being reduced here. So when all these things were being reduced, the material usage, the energy consumptions, the water pollution, land, air pollutions, waste generations, everything when it is reduced here, automatically I say the environment is being protected, and I can say the performance of the environment is improved because of the implementation of sustainable manufacturing. And then comes the social performance. So what is social performance? How this sustainable manufacturing is in detail, it is being associated with the people, those who are working along with the manufacturing scenario. So here, when I should check how far the health of the employee is being improved, how the happiness of the employee is being improved, how how the continuous education process of the employee is being improved, how the poverty level of the employee is being reduced, how the standard of living is being increased. So all these things, it speaks on the social parameters. So when I implement a sustainable manufacturing, so there are several cases we have seen where the agricultural lands were being removed away for the implementation of a manufacturing industry, and thereby the happiness of the farmers it has been not taken into account. So in those cases, we cannot acclaim that, we cannot applaud that sustainable manufacturing is in process. It is not so. The people, those who are working over there, and the neighbors, those who are the people, the society, whichever is very near to the manufacturing industry, they should be also feel that it is happy. So here we are considering the health, the happiness, the education, and then the standard of living. Everything should be also improved because of this sustainable manufacturing. When we see about the education, in most of the industries, there are three different levels of management we have. The lower level management, what they will do, they will never focus on education. They just get the wages. They will just go away after this process is being completed. So this is not to be done. So the continuous education of the process should be also, it should be taken into considerations. So, so when I speak about the sustainability parameters, we have some indexes also. So that is called as process sustainability index. So process sustainability index. So when the process sustainability index is taken into consideration, I will measure each and everything. I will measure each and everything, whichever we have seen that all these process parameters were being considered. So it should be measured and recorded. It should be measured and recorded. So here the several parameters are, we have a machining cost, how we can able to machine, how we can able to find out the index, process sustainable index. We can measure what is the direct cost, we can measure what is the indirect cost, and we can able to measure what is the capital cost. And combinedly we can say how far the machining cost is being improved or reduced. I will just come back to the previous slide. So here, machining cost, it is a manufacturing cost, is an indicator of economic performance. So when I say that economic performance is improved, I say sustainable manufacturing is being improved. How to measure this? I mean, this manufacturing cost, it is given by direct cost, indirect cost, and capital cost. So we have certain rubrics over here. I will just manipulate all these rubrics, and then I will find out what is the cost of generating a product which is being implemented by the sustainable manufacturing industry. Similarly, I will come back to the previous slide. The energy cost, and then we have several parameters of environment, several parameters of social performance, and we can able to find energy. How far we can able to find out how the energy is being consumed for preparing, for manufacturing a raw material into a finished product. What is the production energy taking place during the during the production process, and how the energy is being consumed in maintenance, and how the transportation, the amount of energy is being consumed, and facilities, and then renewable energies it is being done. So collectively, I will take all these parameters. This is an index. So we have rubrics, we have templates. So all these indexes will be calculated, and this energy consumed before the implementation of sustainable manufacturing and after the implementation of sustainable manufacturing will be measured, and they will be compared together, and I will find out how far the energy consumption is being reduced by the implementation of sustainability. Similarly, I can able to find it out for environment. The indexes are, I can calculate the energy, I can calculate the usage of water, I can calculate the restricted material usage inside the industry, I can calculate how the disposed waste is being carried out, and how far the noise pollution is being reduced. So all these indicators, when I measure before and after the implementation of sustainable manufacturing, definitely I say the environmental impact is being calculated. And similarly, in the case of waste management, so the indexes are, we will calculate about the consumables, the packagings, the used raw materials, and how the scrap parts were being measured, and how the scrap parts before and after sustainable manufacturing implementations are coming. So when I say the amount of scrap is being reduced, so I say there is a successful implementation of sustainable manufacturing is carried out. and then operator safety. So the injuries, what are the injuries happening inside the manufacturing industry, it should be reduced. So when the injuries are reduced here, automatically I can say the safety of the operator is highly, it is taken care, and the physical shield. So in most of the cases, the physical shields can be measured through an index by absenteeism rate. So what is absenteeism rate? The employees in the lower level management, the wages, they take absenteeisms regularly. But when I implement a sustainable manufacturing, the absenteeism rate will be reduced because they know that this sustainable manufacturing will provide a highest amount of safety to the employees, those who are inside the industry. So automatically the health of the employees will be improved here, and they becomes a index for maintain for the process sustainability index. And then comes how we can able to implement the sustainable manufacturing in an industry. How we can able to implement. So here we will emphasize on the develop technologies and methodologies. So when I reduce the emission of greenhouse gases, when I use clean energy, when I improve the energy usage, when I reduce the non-renewable or toxic materials and the waste byproducts, all these things collectively, so I can say I can able to implement sustainable manufacturing when I want all these to be implemented in the industry. So several industry, the top level management, they will be having the complete control whether they can able to implement sustainability in their manufacturing phenomena. So when they want all these objectives to be carried out, that is, they want to reduce the emission of greenhouse, they want to improve the energy usage, they want to reduce the waste byproducts, then the only solution here is they have to implement sustainable manufacturing. How this sustainable manufacturing is bringing into practice in manufacturing practice. So we will use. So here we will use the renewable materials which are not depleting the natural environment, and these materials are now they are the input materials and they should be non-hazardous and it should be recycled. And after this I will be moving to the production unit where I can modify the production process to use lesser amount of energy. We need to use lesser amount of energy. So the first two factors, it speaks on environmental factors, environmental parameters of sustainable manufacturing, and third one, it speaks on the energy factor. So in this energy factor, I should use a production process which will use a lesser amount of energy and water, and it will produce lesser amount of waste also. And then it comes to the once the product were been finished inside the industry, from the industry it moves to the packaging industry. It has to be sent out for the public for exporting or for any other purposes. In that case, packaging is a very essential phenomenon in manufacturing, and in this packaging it should use the lesser amount of packaging, and it should use the product of lesser in weight, and it should provide a very excellent logistics and efficient transportation should be provided. And once the transportation is, once the products have been sent out from the industry, it should come to the stakeholders. It should come to the stakeholders, and it should be stored in a warehouse. It should be stored in a warehouse. So in this, when it is being stored here, when it is being sent to the customers and the retailer, it should reduce the environmental impact of sales and distribution. And then the product will be given to the end users for the for the consumers, and this sustainable manufacturing should see that this product, if there is any failure, it should be very easier to repair, and it should need a very few resources for during the process of repair and usage also. And finally, after a particular period of time, this product will deplete, and it should be in the process of recycle, it should be reusable, and it should be remanufacturing. Or simply saying, the manufactured product should be a biodegradable product. So when I implement all these things, I say my sustainable manufacturing is in a successful manner I have implemented, and it has been in process in practice. Then comes the implementation, the scales of sustainable manufacturing. We can able to find, we'll just move the screen. Okay. We can able to find a scale is given here, and we have 5 different cards here. Under these cards, we can able to find a scale, generally easier, and then And the second scale we can able to find is it is more difficult. So it is very easier to have a housekeeping. When I want to implement a sustainable manufacturing, it is very easier to have a housekeeping. It is very easier to optimize. That is, housekeeping means I will make some improvements in the work practices, and then I will maybe go for a better maintenance. When it is in process optimization, I will make some certain adjustments and certain newer methodologies to increase the efficiency of the manufacturing industry. But the tougher side is I should have a raw material substitution. That is, I should provide a raw material which is environmentally friendly, because nowadays the raw materials I should shift from one end to the other end. So when I shift the raw materials from one end to the other end, that is, I should shift the raw materials such that they are environmentally eco-friendly materials. This will take up a very larger amount of time for the manufacturing industry to cope up. And then I should adapt myself, my industry, I should change my industry to newer technologies so that I can able to reduce the waste, I can able to reduce the energy consumptions. So this will involve a higher amount of investment. And then finally, I should go for a new product design, so where it will minimize the impacts throughout the product life cycle. So these three cards, it is little bit tougher for the implementation of sustainable manufacturing. Then comes, we can able to find, then comes the concept of smart manufacturing. So whenever I say about sustainable manufacturing, we are always speaking with three parameters: the social impact, environmental impact, and economic impact of an industry. So this superleads the newer technology of manufacturing, which is called as smart manufacturing. So in the case of smart manufacturing, so this is a very generalized visualization which speaks how smart manufacturing works. The engineers are standing outside, so it is showing that do not enter, manufacturing is in progress. This is what a smart manufacturing will say. So simply you can say a smart manufacturing will take into account that everything will be automated. So industry 4.0 is in existence now. So industry 1.0, 2.0, 3.0, and now we are in industry 4.0. In industry 1.0, the mechanization is in process. That is the development of steam engines, hydro energy resources, agriculture industries, weaving loom, textile industries, everything came into existence in the industry 1.0. And it is started in the year of 1784 and it lasted for around 80 to 90 years, where the high advancements of mechanization, steam power engines, weaving loom, textile industries, agriculture, everything raised to a very certain level. Then came the existence of Industry 2.0, where it speaks on mass production, assembly line, and electrical energy. So here, in the case of mass production, everything is being considered for manufacturing in higher amount of volume. That is mass production. So the electrical power, the usage of electrical power came into existence. So the higher amount of electrical power, motors, sensors, all these things came into power in the 1870s. And control systems were being there, and by the usage of these control systems by the electrical energy, the mass production is being facilitated. It lasted from 1870 until in the mid of 1960s, the mass production is into consideration. Then came the Industry 3.0 by the year 1969, where the rapid growth of electronics, sensors, actuators, automations, computers, the programmable logic controllers, everything came into existence. This is the period where we would have witnessed the higher growth of electronic components into existence. So in the older days, before 1970s, having a television in an certain locality is very higher. It may be one or two televisions may be there for every 100 houses. But nowadays we can able to find every house is been having 2 or 3 laptops or televisions or mobile phones in their houses itself. So there is a dramatic increase in the electronics industry, controller industries, automation industries, in the which came into existence of 1970. And now we are in the scenario of Industry 4.0, where we have cyber physical systems, that is Internet of Things networks is been working out now. I can sit in India, I can do a manufacturing process at France. I can sit in India, I can assemble a car at Switzerland. So all this will take place only because of this higher amount of networking, higher amount of interconnected systems because of Industry 4.0. So Industry 4.0 speaks mainly on cyber physical systems in automation. So we can able to do anything from anywhere else. And this is again a chronological order of Industry 4.0, where in the Industry 1.1 we speak on industrial cities. Industry 2.0 we speak on mass production, that is industrial regions were been developed. Industrial regions are there. We can, there may be, when we speak about Tamil Nadu, Coimbatore is an industrial region where they are focusing towards higher growth in production because of setting up pure industrial regions in and around Coimbatore. So the economics of the scales have been also considered. And Industry 3.0, we are moving towards global production market, and it is purely completely automized. And Industry 4.0, it is robotization, where the global value chains and flexibility are being considered. And Industry 4.0, so the products. So there are several products associated with Industry 4.0. So in all these cases, these products we should be aware, and these products should be intelligent enough. They should be highly connected, and it should be responsive. So we will have a mobile-to-mobile communication device that will interact and exchange the data from the cyber physical systems. And the products whichever is associated with this Industry 4.0, they should be equipped with the sensor technology. So they should have a higher amount of affinity towards sensor technology, and they completely give away the condition information about the products and its environment. And they all the products, smart products, it should be equipped with autonomous decision making and self learning process. So these are the products which we are where the principles of Industry 4.0 lies here. So there are 6 main design principles of Industry 4.0, and the design principles are: it is interoperability, it is virtualization, it is decentralization, real-time capability, service orientation, and modularity. So what is meant by interoperability? Interoperability is the ability of cyber physical system and humans and smart factories to connect and communicate with each other via the Internet of Things. That is called as interoperability. It is very simple. We have several systems, we have factories, we have cyber physical system. All these they should be connected together, and they should also communicate with each other via Internet of Things. That is, they are the Internet of Services. We have ERP, we have supply chain management, we have logistics, we have manufacturing, we have robots. Everything should be interconnected together. That is called as interoperability. So we have information technology and operation technology convergence should be here. That is IT and OT convergence. Internet of Things, information of technology, and operation technology, they should be converged together. And then the people, the protocols, the standards, everything should be connected together. That is called as interoperability. And then virtualization. Virtualization, before the real manufacturing takes place, I should go for a digital production. I should go for a digital production. So this all these things I can do it by means of providing a cloud-based manufacturing. By providing a cloud-based manufacturing, by implementation of several sensors, and then other the cloud technologies. So in what way I can able to do this? I can connect my suppliers, my logistics, and my computer servers, everything to the cloud here. So when it is being connected to the cloud, I can say that the digital manufacturing is being established here. The digital manufacturing is being established here. So in all these cases, what I will do is I will say I can have a physical production where humans will communicate with the robots, and these robots will automatically they will give a higher amount of the effectiveness of the implementation of the smart manufacturing. And then it speaks about the decentralization. So it is the ability of the cyber physical system within the smart factories to make decisions on their own. So what are they? So it should take autonomous decisions, and it should take the semi-autonomous decisions, and it should be intelligence towards the edge, and then they should have a higher amount of deciding authorities. So for example, when a manufacturing industry is carried out, so when the products are produced in plenty, and these products are to be sent to the warehouse for the storage, then this decision should be taken by the computer itself. That is, they will check out what is the amount of production parts that has been carried out in the industry. Then they will call up the logistics systems, and this logistics systems automatically they will send up the guided vehicles, and they will transport all these parts, which are the finished parts, to the warehouses, and from the warehouses they will send it to the sales and other marketing avenues for the products to be sent out from the industry. So all these things, we will not employ a person in so to carry out all these things. So what we will do is everything will be decided by the smart manufacturing industry itself. So for example, when I'm doing a manufacturing, when the raw material products, when there is a scarcity, when I want to find out the tool, when I want to find out a coolant, when I want to find out a lubrication, all these things has to be automated. So yeah, a semi-autonomous decision should be taken up by the system itself. So they will find out. So if I want to have this amount of volume of production for the next target, the raw materials is insufficient. So immediately they will procure, they will send up a signal, they will take up an autonomous decision so that the raw materials may be purchased here. So all these processes were been totally, it is been decentralized, starting from purchasing until warehousing and logistics. Everything is being decentralized. Then comes the real-time capability. So the real-time capability is nothing but, so how far we are going to collect the data during this process of manufacturing. For example, when I'm going to machine a material, for example, we will just take it as an turning operation is being carried out in a machine. How far we can able to collect those the data is more important in a manufacturing scenario. So the data, what is the temperature, what is the coolant used, what is the energy used, so how many parts have been produced, which machine is being used here, which machine is free, what is the time for making a particular product. All these data are to be collected, and it has to be sent towards to the other departments for the analysis purposes. So here, for example, during the first day of operation, when I'm doing a manufacturing a part in a period of 20 minutes, after a period of 1 month, the same part in the same machine with the same process parameters and all the other things, if I take a higher amount of time, for example, 22 minutes are there, then immediately analysis will take part. Immediately analysis why there is an increase in 2 minutes of time for doing the same product with same operating conditions in the same machine. Then this analysis will take place in real time, and the decisions will be taken by the machine itself so that they can able to achieve higher production rate. So what happens when I do all these things, it will automatically, it will reduce the maintenance. That is, the preventive and predictive maintenance are highly, it is being carried out. We can able to find the preventive maintenance and predictive maintenance are being highly carried out. So this is how the real-time capability is being come into picture in smart manufacturing. And then comes the service orientation in smart manufacturing. So in the case of service orientation, so we will find out how we can able to offer the services via the Internet of Services. So Internet of Things and Internet of Services both are interrelated, and we can able to find the cyber physical system, the human and the smart factories, they should offer services via Internet of Services. So here I could say how the people associated with this smart manufacturing, they are being supported by a cyber physical system, and this service economy, how it is being facilitated. So we can able to find we are when you purchase a car nowadays, all your manufacturing of your cars and all, it is taking place only through cloud. And then when you have any problem with maintenance of your car. When you take up your car to an technician, they will just plug. So in the engine side, we will have a USB port will be there. They will just plug the USB port to their laptop. Immediately when they start the engine, this plug, they will collect the complete data of this car. What is the problem? Everything will be populated in your laptop. Where is the problem? What is happening? What is going inside? Where is the maintenance required? All these things will be populated in your laptop. So this is called as Internet of Services. This is called Internet of Services. So and now the technician will analyze what is the problem, and he will support the people via this laptop, and the maintenance whatever is being done or the repairs whatever is being done will be also recorded, and it will be stored in the cloud itself. This is called as service orientation. This is called as service orientation. So we use the Internet of Services, and we will add the value of the customer, and we will focus the everything via the cloud itself to the customers. This is called service orientation. And then comes the modularity. Modularity is nothing but how we can able to go for a flexible adaptation of smart factories for the changing requirements. So nowadays we can able to find the several examples. When the smartphones came into existence, Nokia was the top brand in selling the smartphones, where the size of smartphone is very larger. It is very higher in weight also. Then it lasted in the market for a period of 10 years, and then came into the existence of Samsung phones, and now all Apple, everything it has been in market. So here now the smart factories, they should, so we can able to find there is a rapid change in the design and development of the process for the smartphone which is in market. There is a flexibility in the design. There is a flexibility in the models. There is a flexibility in the technologies. There is a flexibility in operations. Everything there is a flexibility. So when I design a smart manufacturing, when I design a smart factory, I should check out what are the flexible adaptations are possible also, because smart factory implementation is very higher in cost. It is very higher in cost. I cannot go for one product alone. So always I should check for what is the modularity, flexible adaptations I can able to do out. That is, I should either replace the existing model, or I should go for an expansion in the existing model, so that I can check out the needs of the customers. I can check out the needs of the customers. So it should be, the smart factory should be customer centric, and it should be flexible and agility. So I should also see that any unpredictable changes are to be planned. Any unpredictable changes are to be planned. So in all these cases, what I will do, so here I can say my environmental should be dynamic, and I should have a swift changes for my smart factory should be possible. Then comes your cloud computing technology. In the cloud computing technology, actually we have three domains here. We have a user domain, we have an enterprise domain, and then we have a provider domain. So where in the user domain, everything is application oriented. So as such, I have given you an example. I'm taking up a car for any maintenance to a car vendor. A car vendor will sit along with his laptop. He will just plug the laptop to my engine where a USB port is being connected, and he will start the engine. So when the car engine is being started, this will connect it automatically to the cloud, and it will analyze what is happening and what are the technologies available. So all the technologies in the car will be stored in the cloud, and those data will be retrieved here, and they will check for what is the maintenance to be done for the vehicle. And immediately, whatever the problem is been associated, that will be sent to the user to the laptop. That is the technician through their laptop, and with that, the technician will handle the problem, and maintenance can be rectified. This is called a human machine interface through cloud. That is a user domain, and it is an application layer. So how this is being done? This is done by a global service layer which have the problems, which have complete set of analysis to be carried out for rectifying a problem which is happening in a smart factories. So we have again an enterprise solution, and then we have an application programming interfaces in the enterprise domain to carry out all these user domain application layer services. And then we have a virtual service layer, which is a supervisory cloud, and we have a firewall. So when I speak about a firewall, there is a very important technology available in cloud computing. We can say, what is a firewall? So the data whichever is stored here from the user to the manufacturing sector, or from the manufacturing end to the user end, the data will be transferred from one end to the other end. So there is a problem of encryption and decryption. There is a problem of encryption and decryption. So the data whichever is stored here has to be sent to the user safely, and when the user interacts through the machine to the manufacturing sector, that has to come to the manufacturing sector safely. There comes the concept called as cryptography. There comes the concept called as cryptography, which is very emerging technology in cloud computing. So there are several cryptographic algorithms are available, softwares are available. We have AES, we have DES, we have Blowfish. All these algorithms are available. So these algorithms, they will have a firewall technique, so that whatever the data is transferred from one end to the other end, they will be automatically, they will control the amount of hacking, and then the security is being enhanced here. And then all the data will be safely, it will be stored in the cloud. It will be stored in the cloud. So we have several application cloud. We have manufacturing resource layers like computer aided design, computer aided process planning, and computer aided manufacturing. All these things, they will do the operation, they will store everything in cloud. They will store everything in cloud, and this data will be automatically used by the user domain for any purposes which is useful in the future resources. So this is how the cloud computing will look like. We have a manufacturing resource, we have an enterprise resource, and then we have a user resource. Manufacturing resource, they will do all the possible methods of manufacturing by means of applying cloud technologies, and all the data will be stored in the cloud, and this data whichever is stored in the cloud will be used by the application layer by the users, and thereby they can able to retrieve all the informations, and again the information will be passed through the cloud, and we can able to say that the security of this cloud computing, the transfer of data from one end to the other end, is highly controlled by the firewall, and we have the cryptographic algorithms here to safeguard all these data transfers, whichever is taking place here. Then comes how these smart factories, they are associated. So smart factories, we have smart logistics, we have smart buildings, we have smart products, we have smart grids, we have smart mobility, and then smart logistics. Why we have all these things? Because all completely the data, we don't save any data in a separate server. All data whichever we are going to do over here, they will be sent through internet of things or to internet of services, and it is stored in a separate cloud. So whenever I say about cloud, it is nothing but all the informations whichever is done in an industry, it will be served in a separate server, it is a part of internet of things and internet of services. So when I do something, I should have a smart building. I should have a smart building. It defines when I go for an industry, when I take up a manufacturing sector, the machines whichever is associated in doing up a product, they should be having an association of internet of things. That is, they should have a smart sensor, they should have a smart acquisition system, they should have a smart measurement devices. Everything should be smart devices, so that whatever data, whatever things we are doing it in the manufacturing sector, everything will be stored in a separate cloud based storage systems will be available. Then I come the smart products, that is the sensors. When I want to measure a pressure, it should be measured through cloud. I should have a smart device to measure a pen sensor. I should have a smart device to measure a velocity. I should have a smart device to measure a cutting temperature. All these things should be, I should have a smart product. I should have a small product, and these products they should have a facility of Wi-Fi or any internet associated related things. They should have a communication, and then they should be transferring these data via cloud easily. I should have a smart grid. I should have a smart grid. So all my mobility should be through smart mobility. That is logistics. That is, it should be have a GPS tracking system. They should be connected to the cloud. So whatever I'm moving it, they should have some programmable logic controller system. They should have. They should have some grids. They should have some smart chips. All these things they should have. So everything's a smart factory means starting from building machineries, your storage, warehousings, mobilities, logistics. Everything should be associated with by Internet of Things and Internet of Services. So this is an architecture which shows the IoT and IOS, where we can able to find a smart building, a smart logistics, a smart storage, a smart associations. All these will combine together. All these things will combine together, and we so all these things I will just combine together, and then I will find out the management of end devices and systems effectively. So here the services are it is Internet of Services. I can say I will find out the knowledge of business areas and its applications and internet based systems and service platforms. Everything it will be connectivity by IPv6, which is the newer technology available. So in the application side, I should have industry, a smart industry, a smart building, a smart energy, a smart mobility. Everything will be in the level of application, and it is to be access to the customers very easily. Okay, then we will come to the next part of our seminar. What are the research perspectives of smart manufacturing? So actually, this I have taken it from one research paper. So the source is given here in the bottom of the slide. The digital object identifier I have given you. There are 10 areas they have suggested. The researcher has suggested there are 10 areas. The first one is the smart manufacturing can be highly implemented. High research perspectives are available for smart manufacturing in industrial community modeling and simulation platforms for smart manufacturing. This is very important because there are certain people, those who are taking up the research in smart manufacturing nowadays. So when they focus on these 10 priority actions for smart manufacturing, hopefully it will be succeeded. The first community is the industrial community, so where the smart manufacturing can be implemented very easily. Second, the priority heading is industrial data collection and management systems. So here a research focus can be available for smart manufacturing. Third one is the integration of business systems and manufacturing plants and suppliers. That is enterprise and wide integration. That is how we can able to integrate the manufacturing plants, business systems, and suppliers. And last heading is we can able to find out the research aspects in education and training in smart manufacturing. So we will come back to the first one, that is the industrial community modeling and simulation platforms for smart manufacturing. They have given 4 different topics here, on which topics the research perspectives are highly available. So we can able to create in community platforms for the virtual plant enterprise. That is, it is very simple. How the community platforms can be created. That is how we can able to generate the software, networking, all these things. For when you take up a new industry, when you decide all these things, there comes a new research perspective. It can be done. Next one, how far we can able to develop a next generation toolbox for software and computing architecture for manufacturing decision making. So we have to develop a toolbox. So this research perspective is also it is widely open, and it is nowadays this the generation of toolbox of software and computing architectures is highly taking place. Then third one is in the industrial community, how we can able to integrate the human factors and decisions into plant optimization, software and user interface. Again, the optimization come into picture. That is, when we are integrating the human factors and decisions to the plan, it should be optimized. So how far we can able to do this? And fourth aspect of research perspective is we can able to find how we can able to expand the availability of energy decisions, and we can able to find out the new energy apps for mobile devices for multiple industries and diversified skill levels. So there are four different research perspectives are given here. One is how we can able to create a community platform. Second one is how far we can able to develop a new toolbox for the software and computing architecture. And third one is how we can able to integrate the human factors along with the smart manufacturing industry. And fourth one is development of newer apps, a user-friendly apps for the mobile devices for multiple industries to on the diversified skill levels. The second level is affordable industrial data collection and management systems. Here, I can establish a consistent method for all industries to collect data collection and management systems. This is also widely it is been taking place into research perspectives, because the people with engineering backgrounds and management backgrounds, they focus on these areas nowadays. That is how they can able to collect the data from several industries on a separate cloud, and they can able to store it on a separate platform. That is how the research has been taken place, and how to develop a robust data collection frameworks. That is how we can able to collect the data from the sensors, from the machine user interfaces, from the data recording and retrieving tools available in the smart manufacturing industry. So these two areas, the research perspectives are available for data collection and management systems. And then comes the enterprise-wide integrations between the business systems, manufacturing plants, and the suppliers, where it speaks on supply chain performance. Supply chain performance between the users, end users, and the manufacturing industry by means of a common reporting and rating methods. By means of a common reporting and rating methods. That is, we have to develop a common reporting method and a rating method to optimize how the supply chain performance is being carried out in a smart manufacturing industry. And then we can able to provide, we can able to develop a platform for the software and hardware to integrate and transfer data between small and medium enterprises and the original manufacturing equipment. So all these we can able to develop a software or a hardware to integrate how these integrations between business systems and manufacturing plants can be facilitated. And the third one is given here is I can integrate product and manufacturing process models so that I can transfer the data very efficiently. And last one is our sector in the education and the training sector in manufacturing. I can enhance education, I can enhance the training to build a workforce for smart manufacturing. I can create a curriculum, I can create a training module, I can create a design standard and interface, learner interfaces. So all these will come under research perspectives of smart manufacturing. I will just summarize all these things once again. So we have 10 different priorities actions for hello. We will have the 10 different prioritized actions for smart manufacturing. So in the smart manufacturing, we can able to find out there are four different subheadings are given here. The first one is industrial community modeling and simulation platform, and then affordable industrial data collection and management system, and then integration between the business systems and the manufacturing plants, and finally education and the training in smart manufacturing. And we have several avenues are been under all these headings where we can able to carry out the researches in smart manufacturing. And then as established by the National Institute of Standards and Technology. So we have several smart manufacturing research programs are conducted. So where the programs I have shown you four highlighted programs are given here. This is given by NIST, that is National Institutes for Standards and Technology, where smart manufacturing system design and analysis program is there. We have a smart manufacturing action plan, robot system for smart manufacturing, and then measurement science for additive manufacturing. And then a smart measurement science for additive manufacturing. So when you speak on smart manufacturing, I will speak about the methodology, modeling methodology, real-time data, performance assurances, reference structures. All these things will be taken care. When I speak about smart manufacturing action plan, then I will be speaking about wireless platform, digital threats, cyber securities, interoperability, execution management. All these things will be taken care. When I speak about robot systems for smart manufacturing, I will speak about the framework for robot system, and then the performance of the robot system, agility, and then interoperability and integration of robot system. And then finally, measurement science and additive manufacturing. I will speak about the specialization of a material for additive manufacturing, and then verification of the material for additive manufacturing, real-time control, and then system integration and interoperability for the additive manufacturing. Now, what all this speaks about? So, all this speaks about what are the avenues we have in smart manufacturing and what projects we can able to carry out in all this manufacturing process. It has been given here. For example, when you take about robot system, I can just see how I can able to find a evaluation framework of how a robot is being working in a smart manufacturing. That I can do it. How this collaborative performance of a robot system can be assessed. That I can do it. How this robot system can be integrated to the my manufacturing smart manufacturing, that can be analyzed. All these things are the sub projects where I can just say that this can be integrated and how it can be analyzed. Again, I have given you the source here. So through the source only, I have taken all these information. And then what are the strategies of manufacturing information? So actually, there are 13 assignments are given here. Out of this, these 13 assignments were been categorized under 4 strategies. The first strategy is smart manufacturing proliferation, where we have to distribute, proliferate smart factories, develop smart manufacturing technologies, reinforce manufacturing soft power, and promote production facility sophistication investment. That is, when I go for an innovation, now we are not speaking about the networking, or we are not speaking about any cloud computing or smart manufacturing. Now we are speaking about how innovation can be done in smart manufacturing. So here, in the case of smart manufacturing proliferation, I can go innovations in developing smart manufacturing technologies. I can do innovation in reinforcing manufacturing software. I can do innovation in promotion of production facilities. And then the next one is representative new industry creation for a creative economy. So here, what I can do, I can when I want to create a new industry, that is my strategy for manufacturing innovation. What I can do, I can visualize how the smart convergence product. So when I want to create a new industry, I should visualize earlier the convergence products, and I should develop and commercialize these intelligent materials components, and I should promote the R&D, and I should have a higher amount of investment also. Smart innovation of local manufacturing. So when I go for local manufacturing and I go for a smart innovation of this local manufacturing as one of the strategy for the manufacturing innovation, I should have that. I should activate this manufacturing business through creative economy, and I should realize smart locally based industrial complexes and promote locally specialized smart new industries. So business reorganization and innovation-based creation can be facilitated. I should promote spontaneous business. I should promote spontaneous business reorganization by the companies, and I should improve the regularity. I should improve the regularity for the convergence of new products and anticipatory training of the personnel to be facilitated. And these are the components of smart manufacturing. We can able to find there are several components associated with smart manufacturing. So we will start with cyber physical system. We have artificial intelligence, we have a cloud computing, we have big data, and then we have additive manufacturing, virtual reality, simulations, flexible manufacturing system, and then augmented reality. What all these says? So when you take a cyber physical system, I say all my components, my measuring equipments, my manufacturing equipments, my logistics, my buildings, everything should be associated with smart techniques. That is called as cyber physical system. When I say about cloud computing, all my data whichever associated inside my industry should be saved in a separately in a cloud computing device, which should be retrieved by the manufacturing industry and also by the user collectively whenever it is required. Big data. The storage of all the information should be easily retrieved and should be stored in a physical system. Additive manufacturing, where the additive manufacturing is a new method of manufacturing in which the amount of waste which is been generated in a normal manufacturing industry is totally eliminated. We can able to go for high amount of complex parts to be manufactured, and also in additive manufacturing there are more amount of research avenues are available, and it is connected to highly to the smart manufacturing scenario. So I should have a high virtual reality. I should go for a higher amount of simulations through CAPP and CAD. And after all doing all these things, the manufacturing system should be highly flexible so that I can change the design of the systems, whichever is having over here. I can go for higher amount of modularity and flexibility in my manufacturing process. This is the ecosystem model developed by NIST. That is, it is the National Institute of Standards and Technology, which developed a smart manufacturing. So here it is very interesting to see the colors which is given in this figures. We can able to find the domain, different domains of smart manufacturing are being combined together. Different domains are being combined together. We have a green color, we have a blue color, and then we have an orange color arrow mark is given here. So here the ecosystems which provides the correlations between the products are shown by green arrow mark. That is, it starts from CAD, computer aided design and computer aided engineering, design, process planning, production engineering. It comes into the manufacturing pyramid and then goes out as usage and recycling. Completely it is smart manufacturing oriented. We start with CAD, that is the computer aided design, which will be done by means of smart manufacturing terminologies, and then we will go for process planning. We go for production engineering, a highly flexible manufacturing system. CAM is given over here, and then in CAD/CAM process planning we have simulation packages, and this is the product how it has been developed, and the product has been developed. It is going inside the manufacturing pyramid, that is a smart manufacturing pyramid, where we have the devices, the flexible devices, and then we have the enterprise resource planning and smart manufacturing terminologies will be working on it, and then it will come out as an end use, and it will be open for the services for recycling also. This is what shows in green arrow. When we see about the blue color arrow, which speaks about production. So when we see about production, so again we have a CAD. So we are not going to use our normal manufacturing methodologies. We are going to use highly sophisticated smart manufacturing systems where design, development, everything will be automated, and then we will build it and then we will commission it. So once all this commissioning and building is over, then we will go for the decommissioning and recycling. That is, we will enter into the digital factory, and through this digital factory, the parts will come outside via the manufacturing pyramid. And then comes the orange color arrow, where we have as a business model, we have a source, we have a plan, and this plan we will be implementing in smart manufacturing, and then we will go for the delivery. So all these combinedly, we will be calling it as an ecosystem model as developed by the National Institute of Standards and Technology. So we can able to find everything is associated with smart manufacturing. Everything they are interrelated. Everything they have some relationship between one over the other, and no human interfaces will be given here. So everything. So when the design part is completed, automatically it will send it to the. We can able to see the orange color arrow marks. So all process will be automatically it will be moving out. When the process is completed, when it want to go to the next product, they will be coming to the next product automatically. So the life cycle of these enterprises will be completely automated, and it is under the control of cloud computing and smart manufacturing, where all the data will be stored in the cloud. We can retrieve it very easily. And there are several technologies which we come into picture in smart manufacturing. They are virtual reality. Virtual reality means, so we can able to find out what is happening in an industry. We can able to find out what is happening in
இதனால வரைக்கும் நல்லா
We will find out what is happening in the industry, everything virtually, so it is real time. We can go for cyber physical systems. It is there in the smart manufacturing, additive manufacturing, big data, flexible manufacturing systems, in the Internet of Things, industrial Internet of Things, simulations, artificial intelligence. All these things it is there in the smart manufacturing. And what are the components related to National Institute of Standards and Technologies in smart manufacturing ecosystems? So we have product lifecycle development, lifecycle management, supply chain management, design for supply chain management, continuous process improvement, continuous commissioning, DFMA, FMS, manufacturing pyramid, fast innovation cycle. All these components are available in list. We can able to find it over here. We can able to find FMS, DFMA, CCX, CPI, DFCSM, fast innovation cycle, everything is there. So these are the components of NIST. What they will do when we speak about product lifecycle management, they manage the entire life cycle of the product from the inception through design and manufacture to the disposal. This is what it is done in product lifecycle management. Supply chain management, the management of flow of materials, final products, and related information within suppliers, resellers, and end customers. So the complete flow of materials will be managed by supply chain management. Design for supply chain management. They will go for a designing products to take the advantage and strengthen the supply chain. Continuous improvement process. Continuous process improvement. The ongoing process involving engineering and management systems will be redesign and optimization will occur in this process where continuous improvement will be taken care. Continuous commissioning. So the commissioning of the ongoing process, diagnosis, prognosis, performance improvement will be taken care by continuous commissioning. Design for manufacturing and assembly will take care of manufacturers of parts and assembly and easy assembly of the products. Flexible manufacturing systems, they will carry out reconfigurable production types without changing the entire process. That is, flexibility in manufacturing will be taken care. Manufacturing pyramid, so it speaks about the hierarchical structure of an existing manufacturing system, and fast innovation cycle speaks about the improvement strategies for a new production cycle. So this is how the components of manufacturing ecosystems will speak on. And this is the overview of Internet of Technology. So in our Internet of Things architecture, we have several layers over here. Initially, we can able to find we have a physical system. We have a physical system where the physical system is being connected by RFID sensors and several technologies. And these technologies will be connected through the IoT applications via the Wi-Fi Ethernet. And this IoT applications will be connected one together by means of having a smart buildings, a smart home, a smart health, a smart transportation, a smart industry. So we will start with the perception layer, and in between the application layer. So in the to go for a specific application, we will have a network layer. So in the physical system, so everything. So for example, when you take a smart health, so we will have a smart watch. So nowadays we can able to find out what is the amount of sugar level in our body by using a smartwatch. What is the amount of pulse rate by using a smartwatch. For this smartwatch, what it will do when I go for a walking, I will fix some steps, amount of steps to be going for a walking here. Automatically, it will start making calculations, analyzing how many steps I am moving away. So when I move to a particular amount of steps, it will just tell me that you have achieved your target for this day. If not, it will take up the own decision. It will send us the signals via the cloud to our smartwatch. This message will be given so that I should carry out some amount of exercise to reach my target for the today's target. This is what is happening here. Similarly, in the case of smart transportation. So how all these things are done is it is mainly by means of sensing elements which is associated in the smart manufacturing scenario, and also the machine learning technologies. How far we can able to communicate between one end to the other. And what are the challenges? Now I'm coming just. I'm going to summarize the overview of the seminar. What are the challenges in smart manufacturing? We have higher amount of security issues. So this is what a high amount of research is going on in cryptographic algorithms. How far we can able to control, how far we can able to reduce the amount of security threats in transferring one data from one end to the other end. how system integration is associated. In smart manufacturing, everything starting from logistics, transportations, machining, manufacturing, measurements, everything is real time and it is to be integrated one over the other. But that becomes a big problem in smart manufacturing. And then interoperability. I saw again the same thing. So how we can able to operate from one server to the other server so that the data can be transferred effectively. Safety in the human robot collaboration is a big threat, and return of investment. So I will be having a very higher amount of investment to the smart manufacturing scenario. But as an businessman, when I speak on investment returns, that is a question mark here. So when I have a higher amount of return, then automatically smart manufacturing should also go for a higher amount of investment. But this is whether it is possible, and the return of investment is also possible. Is a very big threat. So this is the summary of my lecture. So the defined functions of the smart manufacturing. So in the current manufacturing scenario lacks a big gap from the conceptual smart manufacturing systems and the existing manufacturing systems. So there is a very big gap between the smart manufacturing and existing manufacturing systems. And this is to be avoided. This is to be, so this is the research perspectives where we can able to analyze all these gaps and we can able to focus on the 10 perspectives which is shown in the slides, the research perspectives of the smart manufacturing. For the proper communication between the machines and industries, there should be implemented the latest technology which supports more devices in interconnection, which supports more devices in the interconnections. So this is how we can able to find out the smart manufacturing and its related scenarios in the present world. So with this, I conclude my section. Dr. Taman,
Yes, sir. Thank you so much, sir, for your
I open the
wonderful.
session for the queries.
Yes, yes, sir. Wonderful session, and you have really provided in depth of smart manufacturing, its scopes and research and challenges. So now I request participant, if you have any doubt, you please ask to sir. The session is open for discussion now. Sir, I have one doubt, sir. I
Yes,
have one
please.
query, sir.
Yes.
So how this you have shown the three aspect of sustainability, right, sir? In that uh,
Yes.
in one
Yeah.
figure. So how this social aspect can be achieved how this social aspect is related to achieve this sustainability, sir?
Yeah. This actually that there are three different parameters in sustainability. One is
Yes.
social aspect, and second one is environmental, and third one is economic aspect. Social
Okay.
aspect it speaks on the persons those who are working in the industry. For
Yes, sir.
example, when a person working in the industry is happier, automatically the production rate will be improved. When the
Okay.
health of the employee is very good, automatically the production rate will be improved. So the sustainable manufacturing it speaks on the social aspects, means how we can able to improve the health of an employee, how we can
Okay.
able to improve the continuous learning process of an employee, how we can able to improve the happiness in an employee. That is what is called as social impact of sustainable manufacturing.
Okay. So is there any measurement so that how it can be measured, sir? How suppose a person, suppose a worker is happily working in the whatever the assigned job, how it can be measured, sir?
Yes. So when you take up an industry, you can go for checking an absenteeism rate. So
Okay, sir.
when an employee is frequently absent for a duty, then it shows that he is not interested towards doing that manufacturing. She's not working to that manufacturing industry. She's not happy. Just coming over there and going away, but he's not putting his complete concentration in improving the sustainable manufacturing. So when you take up the health of an employee is a serious threat. Continuously, when the health is not proper, he is very tired, he is very fatigue, he is not able to stand for a particular hours, he is not able to communicate with his peer group very happily, then that is a problem. Then it shows that the social impact is to be improved in that industry to achieve a sustainable manufacturing. So this is how we can able to measure.
Okay, sir. Thank you, sir.
Thank you.
Any more doubt from the participant? Sir, some participant has written in the chat box that you could please share the PPT, sir, your presentation slide
And
of this
definitely,
session.
definitely, I will share it to you, Tamang, Dr. Tamang.
Okay,
You can
okay,
send it
sir.
to the participants.
Yes, sir. Yes, sir. So, participant, if there is no more, if there is no doubt, then shall I conclude the session? Thank you, sir. Thank you so much for accepting our invitation and delivering such a wonderful talk on the smart manufacturing. You have really covered the all the uh, from the basic, that is from the foundation to the scopes of the research. So if someone is new to the field, or someone is doing uh, they are planning to do some research in the smart manufacturing, then I hope this lecture was beneficial for them. Thank you so much, sir.
Thank you. Thank you. Thank you all. Thank you all. I will share this slide. Thank you all.
Okay, sir. Yes. Thank you, participant, for joining this first technical session. So our second technical session will start at 11:40 as per the given schedule. As per our schedule, the second session will start at 11:40. So till then, you stay connected, and if there will be a, if you want to take a break, then you may go for it. So please join at 11:40. Thank you. And the participant attendance of all the three session of day one will be taken at the end, at the last session, that is in session 3 at 4:30. So at after 4:30 we will be sharing you the one Google form where you are where you have to fill the attendance. Any doubt if you have, then please ask.